Okay, let's start. Hello, everyone. Welcome to the 29th International Symposium on High Performance Parallel Distributed Computing, ACM HPDC 2020. So my name is Vladimir Vlasov. I'm a professor in computer systems at the KTH Royal Institute of Technology in Stockholm, Sweden. And I'm a general co-chair together with Professor Manish Parashar, and as well as local co-chair of the ACM HPDC 2020 Symposium. And I will moderate this live webinar. Before we proceed, I would like to mention that I'm sorry, but you will not be able, and furthermore, we don't expect you to use your microphones for questions and comments, but rather you can post your questions and comments, if any, in Q&A on the Zoom control panel. So you find Q&A, question answers, and then you post. And we will do our best to answer your questions by text during the webinar so that we don't interrupt. And if time allows, we can also answer some questions live at the end of the webinar. You can also post copy of your questions and comments to the webinar Slack channel. Just find the Slack channel, which is called webinar, Q&A webinar, and then we can answer your questions, comments asynchronously after the webinar. And let me now introduce our panelists or speakers. Okay, first, let me show you just one by one. Manish Parashar, Professor Manish Parashar from Rutgers. Manish, maybe you can wave your hand just to show where you are. New Jersey. He is General Co-Chair of HPDC 2020 and he has done a good job of organizing the conference and lead the organization team. Okay, the next. We have two program co-chairs. Okay, let me show you. Catherine first. Catherine Moore from Lawrence Livermore National Laboratory. And I'm controlling also at the same time, therefore I'm a bit slow. And David Irwin from University of Massachusetts Amherst. So we have two program co-chairs, as you see, they're located on different coasts of United States, one in California, Catherine, and David in Massachusetts. So, but even being so far from each other, they did really great job by, organizing review process and paper selection process, and then forming a program, which is, in my view, is really very interesting. Okay, the next I want to show you, let me just change the window. So, Antonino Tumio from Pacific Northwest National Lab, he's workshop chair. And he also did a very good job of actually setting up workshops allocated with the HPDC 2020. Initially, we planned to have 4 workshops that has been selected, but unfortunately, because of COVID-19 situation, 2 workshops have been canceled. But 2 workshops will happen tomorrow live. So therefore, I encourage you and invite you to attend, if you will, workshops tomorrow, June 24th. I was expecting also, just let me put my video back. I was expecting also Professor Jan Weisman, who is chair of steering committee, but he might come later, and also George Ambrosiadis from CMU, publication chair. But I would like to give a credit to George because proceedings all of papers are available in ACM Digital Library. Yeah, now I can just show you. So where they are. So you can find links on the, I hope you can see my screen. So you can find links on the front page of the conference. Here it is, proceedings of, as well as in the program, also there is a link. And these proceedings are on ACM Digital Library with free access. And then you just use navigators, you go to a session which you're interested in, for example, this one, and pick up a paper that you want to read. And so you have a PDF of the paper, and also please look at supplement material, which is MPEG video of presentation. You can download it and watch it asynchronously. And also I would like to just to point that all videos of presentations are also available from the program page of the conference. As I see that there are quite many attendees, now 50, and there are much more people who have registered for the symposium. So to get an access to all symposium material. And we, organizers of HPDC 2020, we are really glad to see all of you, so many registered participants. And thank you so much for your interest and support. So I really thank you in advance. And also thank you for joining this webinar and for virtually attending the symposium. Just a few words that this symposium on high performance parallel and distributed computing, HPDC, is the annual conference for presenting the latest research on the design, implementation, evaluation, and use of parallel and distributed systems for high-end computing HPC. So initially, HPDC 2020 was planned to be held in person as a physical conference as usual on this very date in Stockholm, Sweden. So you can see a picture in my background of Stockholm and City Hall, and actually see nice weather. And if I look at you, it's really this nice weather, and that, well, let's see here, 27 degrees, and tomorrow is going to be 29. And it's really, I'm really sad, and it's really pity for us that you cannot visit our beautiful city. And my university, KTH Royal Institute of Technology, was planned to hold this conference. But I hope maybe we will make it next year if steering committee will decide to run it again in Stockholm. And I hope the situation will improve and we can make a physical conference. But sometime in late March, the steering committee and organizing committee have decided to cancel physical conference and to run HPDC as a virtual conference or remote online conference. And we made, we put an effort to collect all materials and make it available for free to you, so that we can find that all papers are published and available at the ACM Digital Library. Keynote talks and papers have been pre-recorded by speakers and posted to special HPDC YouTube channel. And you can find links on the program of conference website. And also each paper speaker and co-authors will host live interactive Q&A session via Slack. I hope most of you, if not all, are familiar with Slack, which is like a messaging system. In my view, it's quite effective, efficient, and relatively easy to use. And we have created a number of channels. So each paper has its own channel, and set up a live sessions, which you can find scheduled in program on conference website, so that you can an ability to interact with authors and ask questions, comments, and maybe get in more direct contact with them. Okay, let me show again this Slack channel. Just give me a second. Here it is. So that's in web browser. Otherwise, I can show also in Slack client. So you can browse channels. Here is a channel browser. You can browse them and you can search for channels and find that section that you would like to talk to authors. Okay, we cannot guarantee, but we agreed with authors that according to the schedule, they will be available and they can answer and chat with you. Okay, I'll stop sharing it. So that's about Slack, and Stefano, he will say more about this when he will talk about logistics. So the remaining part of this webinar includes a welcome and introduction by the general co-chair, Manish. He will speak first, and then technical program co-chairs, David and Catherine. So they will summarize the program. Then there will be a presentation by workshop chair, Antonino, who will talk about workshops, and then Stefano Markidis, who is local co-chair, he will tell you about some logistics, how to access material of this conference online. And then we will have a so-called 1-minute madness session. You have seen it in the program. So it's a video with review of each and every paper in the conference. So each and every paper is given 1 minute of author to present, very shortly to present what this paper is about. So this video will take about 22 minutes, actually exactly 22 minutes. And I really encourage you to carefully look at it. Just spend 22 minutes to look through the papers. 1 minute each paper, so that you can get an impression which paper you would like to read in more details, and talk to authors. So please carefully look at this video. And then we will proceed to Best Paper Award. So we have 3 nominees, and David will present them, and eventually we will decide who is the winner. And finally, we will have Q&A session. If time allows, we expect you to post your questions in Q&A. And then we will conclude. And hopefully, if Jan Weisman, head of steering committee, will join, he might talk about HPDC 2021, next conference. And again, to remind you, there will be Slack live channels according to the schedule, and tomorrow will be live workshops. Okay, now I'm going to start slideshow, and we will start presentation. Let me just find it. So, and I would like to pass a microphone to Professor Manish Parashar from Rutgers University, New Jersey. So he is a general co-chair of HPDC 2020. Manish, you unmute your microphone and please.
Okay, go ahead. You can advance the slide. Thank you, Vladimir. Hello, everybody. I'm Manish Parashar. I'm general co-chair along with Vladimir. I'm from Rutgers University. As general co-chair, we really have 2 tasks. The first one is to add my welcome to Vladimir's to the conference. We were hoping to welcome you in person in beautiful Stockholm, but unfortunately, we have to do this virtually. We hope that you're all doing well and staying safe. So welcome to this conference. And our second big task is to say thank you. And that's really important when you have such a fantastic team, right? And this year was challenging, as you can imagine. We have been working on an in-person conference through most of the planning period, and then we had to change very quickly to a virtual event. And it's quite incredible how this team was, with great agility, was able to move and put together a really extraordinary virtual event with a strong program and all the other activities. So again, a big thank you. Let me walk through the key volunteers. As you can see, it takes a village, right? We have the technical program chairs, David Urban and Catherine Moore, who did a fantastic job, and they'll tell you all about the program that you will have a chance to see over the next couple of days. Local co-chair Stefano Markides and Vladimir Vlasov, publication chair George Ambrosiadis, workshop chair Antonino Tomio, poster chair Carl Chod, sponsorship co-chairs Ali Anwar and Zhe Zhang, student program co-chairs Rong Gay and Dong Li, publicity co-chairs Kento Sato and Yon Raiku, and web chair Pradeep Subedi. All of them deserve a lot of a really big thank you for the tremendous effort, especially over the last few months. I'd also take an opportunity to thank our sponsors listed there, as ACM, SIG HPC, and SIG Arch. We have NSF, University of Arizona, KTH, and Castor. I'd like to thank the steering committee and the program committee for their dedication. And most of all, I'd like to thank all of you for participating. And I hope you have a exciting and fruitful event over the next couple of days. Again, welcome. And I will hand it over now to the program co-chairs. Vladimir, you want to go back? Perfect. Over to you, Catherine and David.
Hello, my name is Catherine Moore. I'm from Lawrence Livermore National Laboratory, and I am one of the technical program co-chairs this year, along with David Irwin. And I'd like to give you, first of all, an overview of what we have for you for the technical program this year. First of all, we have this live welcome and introduction session. And then after this, for the rest of the week, we have both asynchronous and synchronous portions of the conference for you to check out. So first of all of our presenters have made videos of their talks and made them available both on YouTube and the ACM Digital Library. And you can find links for the videos on our program webpage. So go ahead and check that out to get the links. We have two very exciting keynote talks, one from Mary Hall and one from Kostas Bekas, as well as 16 full paper presentations and 6 short paper presentations. In order to ask questions of the presenters, we've set up Slack, as Vlad was telling you. You are welcome at any time this week to log in to Slack and find the channel for the presentation that you're interested in and ask questions of the presenter on that channel. In addition, we have scheduled 20-minute live Q&A sessions with each of the presenters, and you can find the schedule for that on our program page, as well as links to each individual channel for each paper. And just as a reminder, just as you would be courteous in a live conference, please also be just as polite online as you would in real life. In Slack, we also have channels available for general questions about the conference. For example, there's a conference help channel. You can also join the hallway channel to talk about random things that you might talk about at the conference itself. In addition to the main conference program, we also have 2 co-located workshops, which are also being held virtually. These are PREX and SNTA, and we'll give you more details on those later in this presentation. Next slide, please. For the main conference program, we have organized it in 2 sessions. And we want to thank the members of the program committee who stepped up and volunteered to manage each of the sessions. This actually turned out to be more work than it would be for a live conference, so we really appreciate them going above and beyond. The first session we have is a keynote session. Again, our keynotes are from Mary Hall and Custis Beckus, and we'll get more details on those later today. And then for the technical paper sessions, first we have improving accuracy and efficiency of algorithms, exploiting the best performance out of GPU accelerators, approaches for mapping learning to distributed systems, big data management and includes analytics, enabling adaptivity of both algorithms and architectures or systems, high performance networking, and improving cloud software and infrastructures. Next slide, please. For the paper review process, first of all, we had 71 submissions, and we had 2 rounds of review. In the first round, all of the 71 submissions were assigned 3 to 4 reviews. And upon receiving those reviews, we made a first cut in the papers, and 48 papers made it to the second round. We assigned another 3 to 4 reviews per paper for the second round. And in total, we received 314 reviews across the 2 rounds. And we want to thank our program committee for providing insightful and thoughtful reviews for each of the papers. And we also had online reviewer discussion after each round to help the reviewers come to consensus on their decisions for the papers. Just like it was a normal year, we planned for a program committee meeting, but we planned it to be in person, to be held in the Boston area on March 19th and 20th. However, due to obvious reasons from the coronavirus situation, we canceled the live meeting, or excuse me, the in-person meeting, and switched to a virtual meeting. We did this at pretty much the last minute on March 4th, and we were very impressed with the dedication that our program committee showed and understanding in the short notice cancellation, and we had nearly full attendance for our virtual program committee throughout the 1.5 days. And we were also very impressed with the amount of attention and rigor that the program committee paid to the virtual meeting, just as they would at an in-person meeting. In the end, we accepted 16 full papers and 6 short papers. The full paper acceptance ratio was 22.5%, and if you include the short papers as well, our acceptance ratio was 31% this year. Next slide, please. We had 50 excellent program committee members that are listed here, and really want to give a big thank you to them. As I've said in the past couple of slides, they provided thoughtful and insightful reviews, really were engaged in discussions and the virtual program committee meeting. So thanks to all of them. Next slide. And even more thank yous, because this is a virtual meeting, we asked our authors to record their talks and submit them so that you could watch them. And because this is the first time for a lot of us, probably most of us, recording videos of our talks, we asked for members of the program committee and the steering committee to volunteer to help us review the videos, to give some feedback to the presenters, to let them know, how good the audio quality was and things like that. And so we're very thankful to these committee members that stepped up to give more of their time to ensure an excellent technical program. And we also want to thank all the authors who really did a great job on all their presentations. And I know you guys will enjoy them, so please check them out on YouTube and the digital library. Next slide, please. And now I'll hand it over to David.
Yeah, thanks, Catherine. So I'm David Irwin, the other technical program co-chair from the University of Massachusetts Amherst. So I just wanted to say a few things about the Best Paper Award and the Best Paper Award selection process. So we had 3 Best Paper nominees this year, and These three papers were nominees because they clearly separated themselves during the review process from all the other submissions. So these three nominees collectively received uniformly positive reviews during the review process, which, given the level of technical quality demanded by the program committee, is pretty remarkable. So collectively, out of 17 reviews through the 2 rounds of normal review, all of these reviews were positive about these papers. And in addition to those reviews, we actually selected a Best Paper Award committee, and thank you to those who served on the committee, that provided additional reviews of these papers. So that committee consisted of 5 distinguished members of the community that each provided an additional review of each of these papers. So in total, we had 32 total reviews across these 3 Best Paper Award nominees. And I want to say something about each one of the nominees before we see the 1 Minute Madness session, and then before we award the best paper at the end here. So advanced slide. So for every review for the Best Paper Award Committee, they reviewed each of these papers and made comments on them. So our first nominee is High Accuracy Matrix Computations on Neural Engines, a study of QR factorization and its applications, by Xiaoshui Zhang, Alaya Barwi, and Panru Wu from the University of Houston. So some of the comments on this paper were, I like the ideas of exploring data locality, also the fact that this is a timely topic. Lots of clever ideas in this paper. In particular, a novel recursive QR is proposed that exploits the tensor core on V100 GPUs, resulting in 3 to 14.6x speedup, and is very well executed. And a well-executed paper that targets a key problem of QR factorization. So advanced slide. So our next Best Paper Award nominee was Spying on the Floating Point Behavior of Existing Unmodified Scientific Applications by Peter Dinda, Alex Bernat, and Connor Hetland from Northwestern University. So some of the comments for this paper. It has a simple idea. It is very well written and with a strong evaluation. An elegant and clever solution to a very important problem, understanding floating point operation behavior for scientific applications. And finally, FP SPY has the potential to play an important role in facilitating further research to better understand floating point behavior, monitor applications at runtime, and evaluate future fault tolerance techniques. So advanced slide. And finally, our last Best Paper Award nominee, DCDB Wintermute, enabling online and holistic operational data analytics on HPC systems. And this one is by Alessio Netti, Mika Mueller, Carla Guillen, Michael Ott, and Danielle Tafani from Leibniz Supercomputing Center, and Jens Ozer and Martin Schultz from the Technical University of Munich. And so some of the comments on this paper, it was a good read, targets an important problem of monitoring and offers a well thought out solution, a nice open source solution for gathering operational data for HPC systems. This paper presents design choices and implementation choices for a production ready framework. And I like the systems approach to the design. The case studies are pretty neat, especially the job behavior analysis. I believe the results will have good impact. So I want to congratulate all of these nominees. They'll be called out in the 1 Minute Madness video. So you can kind of, if you don't remember these names, you can see the video for each of these nominees, and it's specified. And then after that video, we'll present the Best Paper Award. But right now, I just want to say that all of these nominees were clearly deserving of the Best Paper and were really distinctive and stood out in the review process. So advanced slide. So we have 2 keynote speakers. And so we want to thank both keynote speakers. When they agreed to give the keynote, it was in our pre-COVID era, and they stuck with us after we moved to the virtual conference. So our first keynote speaker will be Kostas Bekis. He's head of quantitative development at Citadel Securities. Previously, he was a distinguished researcher and manager at IBM Research Zurich. He's a 2-time recipient of the ACM Gordon Bell Prize. And his keynote title will be Cognitive Discovery, Accelerating Technical R&D with AI. So it's going to focus on using AI to achieve scientific knowledge extraction by intelligently designing and guiding simulations in order to dramatically accelerate the pace of scientific discovery. So we'll look for that. Next slide, please. Our other keynote speaker is Mary Hall. She's a professor in the School of Computing at the University of Utah, and her research focuses on bringing together compiler optimizations targeting current and future high-performance architectures on real-world applications. She's also very distinguished. She's an IEEE fellow. She's an ACM distinguished scientist and a member of the CRA board of directors. Her keynote title is High Performance is All About Minimizing Data Movement, and discusses the role of packed data layout in optimizing data movement across a variety of different architectures, CPUs and GPUs, and memory systems. And so I want to thank both keynote speakers, and I also just want to point out that in addition to the, Vlad and Catherine both talked about the Slack sessions, just to emphasize that our keynote speakers also have Slack channels. They also have, just like the papers, a scheduled synchronous Slack time that's on the HPD website, in addition to the ability to interact with them asynchronously. So I want to thank both keynote speakers. Advanced slide. So Vlad, can you advance the slide? And so now I want to pass it over to our HPDC workshop chair, Antonino Tomeo, and he can say a little bit about the workshop organization.
Thank you, David. I'm Antonino Tomeo, workshop chair for HPDC 2020. And I want to talk a little bit about the workshop organization. First thing, we got 4 workshop proposals that were originally accepted: PREX, SNTA, CCIW, Science Cloud. Unfortunately, due to the COVID, it's difficult to organize a workshop already, and it becomes even more difficult when during the paper submission process we have issues coming in, right? So unfortunately, out of these 4, only 2 continue. But I still want to thank all the organizers for the hard work in setting up the events and trying to go forward. As Catherine anticipated, however, we have to be happy to 2 great workshops are going on, PREX 2020 and SNTA 2020. They are continuing as virtual workshops, and they will start tomorrow with live sessions in different ways and you have the chance to attend them. Please, next slide. So regarding the logistic, as I said, both the workshop will formally kick off tomorrow morning. They will be both will start at 7, but with slightly different organization logistics. For PREX, the 3rd International Workshop on Practical Reproducible Evaluation of Computer Systems, we will have a synchronous virtual workshop with presentations all live on Zoom. So the workshop will start at 7 a.m. and last until 12 a.m. Pacific time. Please do the right conversion. And you should have received a link in email if you registered for the conference, for the World Conference, for the World HPDC event. And the workshop has also a Slack workspace to keep the discussion going after the presentations. For SNTA 2020, the 3rd International Workshop on System and Network Telemetry and Analytics, the workshop will be similar to HPDC logistics. So there will be a live session focused only on question and answer for the presentations. The videos are already available on the site, on the website, so I suggest to start looking at them. And if you have any questions tomorrow, you will have a chance to ask and discuss with the authors. Again, the slides show the link, of course, for the Zoom session. Of course, this is also available on the website. The password will be provided through email. And also for SNTA, there is a Slack workspace so that you can, like for HPDC, ask questions to the authors and continue the discussion after the actual live session. And that's all for the workshops. Again, I want to thank the workshop organizer, and I hope you will enjoy also the workshop event at the HPDC. Thank you very much.
Hello, everybody. My name is Stefano Marchidis, and I work at KTH, Royal Institute of Technology, and I'm a local co-chair of HPDC 2020. I just want to say a few words about the logistics. All the videos of the presentation are available on YouTube. You see here a link to a playlist with all the videos. In addition, we have all the videos, the links to the videos on the program, on the HPDC 2020 website, and also in the Slack channels for a particular paper, we posted the videos. All the interaction between attendees and participants in the conference will occur via the Slack channel, together with an invitation to this section using Zoom. You should have received an email inviting you to join the Slack workspace. Please use your real name as your Slack handle, exactly like you would do for a badge in a real conference. Remember to adhere all the time to the ACM policy against harassment. By default, you have been added to a couple of channels, particularly the one called announcement. However, you will need to practically choose the channel that you want to add in your Slack workspace. So each paper has its own channel for following up the discussion. So in order to add that particular channel on a particular paper, you need to use the Browse Channel button in Slack and add the paper that you want to follow. So that's all I want to say about the logistics. I think now we can go back to David for the next slide.
Yeah, thanks, Stefano. So I wanted to say a little bit before we play the 1 Minute Madness session video. So as Vlad and Catherine both mentioned, we asked all of our authors to upload kind of a 1 minute advertisement of their work that we're going to play now. It's also available on YouTube. And so, you know, when we asked authors to do this, we actually did not give them much direction on how to do it. And so as you'll see in the video, different authors made different artistic decisions about the video. Some are kind of straightforward talks. Some have some production quality to them. There's at least one video, or certainly there's one video where the authors chose not to use audio. So if you feel like the audio fell out, it could be your audio, but it could also be that one video. And so I actually think that it's kind of interesting, and it gives really a nice preview of the conference. This again is available on YouTube as well, but we're going to play it right now to give everyone kind of a sense of the conference. And so I guess Stefano, you can go ahead.
Okay, now Stefano, if you can show.
It seems tensor core, tensor processing unit, and some other accelerators called neural engines are quickly emerging and are likely to reduce the importance of neural networks. It will be a waste if such devices are limited to neural network training only. In this paper, we explore the use of tensor core in matrix factorization so as to accelerate scientific, engineering, and data computing significantly. Matrix factorizations are the workhorse for many computation tasks such as linear solvers and numerical optimization. We will investigate QR factorization particularly in this paper. We show that the severe imbalance of matrix multiplication speed relative to others demands a change of our algorithms. To realize the goal of the mixed precision QR factorization on tensor core, we must go through the intricate interplay between microarchitecture, performance engineering, algorithm design, and numerical analysis.
Hello. We present a new space-efficient storage format for sparse tensors. Our goal is to decrease the time spent pre-processing sparse tensors before they can be used in the desired calculation. We focus on decreasing the space requirements of sparse tensors using a storage format which is inspired by KD trees. Our storage format significantly decreases the space requirements of stored sparse tensors whilst retaining the efficiency of sparse tensor vector multiplication.
If it happened to you to write some C++ code recently, you probably know the parallel STL. It is a way of porting sequential code into shared memory parallel code by simply adding one parameter to a function call. This is very nice. This has been using a lot. But what about distributed systems? What if I want to port sequential code into distributed code? Well, you can't. And that's the problem we target in our work. We propose a design and implementation of the first distributed STL, where you can get from sequential to distributed code in the same way as for the parallel STL. We ended up with a pattern-based design and implementation that is very scalable, not only in terms of performance, but also in terms of extensibility. Indeed, we were able to cover most of the STL in a reasonable implementation effort. So we think our work can serve as a base for future works on simplifying distributed C++ programming.
Greetings from Northwestern University, which is located in the Chicago area of the United States. We would like to encourage you to attend our talk, which is on spying on the floating point behavior of existing unmodified scientific applications. So what is this talk about? So there are three main points. First, IEEE floating point has numerous gotchas and has spawned a cottage industry of building tools and understanding users and codes using them. Our contribution to this space is a system called FP-Spy. This is a user-level open source tool that is agnostic to language and parallelism and records issues in existing unmodified application binaries as they run using hardware mechanisms. We apply FP-Spy to about 10 million lines of code comprising applications and benchmarks that are widely used, and we report on the results. Thank you.
Hi everyone, this is 1-minute introduction to our work, CubeShare. Our work is motivated by increasing demand for running GPU workload in container clouds, but existing platforms like Kubernetes are still lack of resource management support for GPU. In particular, there is no resource sharing and isolation for GPU, and GPU hasn't been treated as a first-class resource, so the binding between containers and GPUs cannot be controlled by resource manager. Therefore, we propose and implemented CubeShare, which is the first work to make GPU become first-class and shared resource in Kubernetes. As shown, CubeShare allows users to specify which GPU and how much resource to be allocated in their resource request. Comparing to native Kubernetes, CubeShare enables fine-grained GPU sharing to increase GPU utilization while addressing performance interference problem. Our implementation introduced little overhead and is compatible with existing Kubernetes framework. We welcome you to read our paper and try our code for more details.
This is Dong Jie Tang. Today we will share a topic called G-Remote API Forwarding Powered Cloud Rendering. The appearance of remote API forwarding system brings many benefits, including having the potential to fully utilize the client-side resources and improve the server utilization by borrowing hardware resources from other machines. However, it still faces one big limitation: shared resource interference, which comes from two aspects: GPU race caused by GPU overuse of a single application, and the CPU race caused by the CPU shortage among multiple applications. Based on this, we designed our own framework, gRemote, to solve this issue. Compared to the conventional remote API forwarding architectures, gRemote innovates 2 units. The library step to minimize the server-side CPU pressure, and the GPU throttle to limit GPU usage of each application. Later, we will compare it with the Amazon Elastic GPU, a closed-source and state-of-the-art commercial product which has a similar targets with the gRemote. If you enjoy our work, and please come to join us on June 23rd, 2020. Thank you.
Hi, my name is Dongnin Yang. I will introduce our work, Efficient GPU Memory Management for Nonlinear DNNs. DNN has been the most popular research area in recent years, and the model size is becoming larger and wider. Unfortunately, the GPU memory growth rate is slower than what we would like. The memory shortage of GPU has been a great challenge to train a large DNN. We utilize the memory swapping strategy to support larger models. Our paper focuses on optimizing tensor swapping strategy and memory allocation for tensors. For more details, please come to our presentation section.
Hi everyone. We study the acceleration of deep learning using huge clusters. We propose the novel technique for large-scale deep neural network training. First, I'll explain the problem. In the training, when we use a lot of GPU with data parallelism, the throughput increases linearly. On the other hand, if many GPU are used, the validation accuracy starts to decrease. Many related works can prevent the decreasing of validation accuracy and increasing the number of GPUs. We also propose a new technique which prevents the decreasing the validation accuracy. In the evaluation, we have trained Latency for ImageNet dataset using 3072 GPUs. This training completed in only 62.1 seconds. If you are interested, please see our session. Thank you.
Hi everyone, we present TIFL, a tier-based federated learning system. In this work, we demonstrate how resource heterogeneity and data quantity heterogeneity impacts the model training time in a federated learning system. We also demonstrate how the inherent data quality heterogeneity impacts the model performance in terms of training accuracy. Based on our observations, we propose TIFL, a system that mitigates the training time delays due to stragglers without compromising the model accuracy. TIFL is built atop of traditional federated learning systems with 2 additional modules. The first one is profiling and tiering algorithm. This module is responsible for splitting the devices into different tiers based on their training latencies. And the tiering scheduler is responsible for selecting clients every round without impacting the model accuracy such that the training time is minimized. Thank you.
As HPC systems grow larger and larger, their needs for energy increase dramatically, and obtaining efficient and resilient operation is a tough challenge. For this reason, we have created DCDB, an holistic monitoring framework for HPC systems. Wintermute extends DCDB and enables online and holistic operational data analytics for production HPC platforms. By using Wintermute, we can easily apply operational data analytics to improve the operation of our systems. It is a flexible, scalable, holistic, and modular framework. Both DCDB and Wintermute are open source projects. If you're interested, check out our HPDC 2020 talk about Wintermute.
Hi, I'm Kai Zhao. The paper I will be presenting is significantly improving lossy compression for HPC data size with second-order prediction and parameter optimization. In this paper, we improve the data prediction accuracy significantly by second-order Lorenzo predictor and second-order regression predictor. We design an efficient approach to select the best parameter settings by conducting a comprehensive prior compression quality analysis and exploring an online controlling mechanism. We evaluate the compression quality and performance of our solution on Bebop supercomputer and experiments with multiple real-world HPC simulation data sets show that our solution can improve the compression ratio up to 46% compared with the second best compressor.
Hello, my name is Songgang Kim. I'm a PhD candidate from Seoul National University in Seoul, South Korea. This is a brief introduction of our paper towards HPC I/O performance prediction through a large scale of analysis. The goal of our paper was to predict the I/O performance of HPC applications. To do this, we created an integrated database using various system logs and used various machine learning algorithms to predict the performance. The evaluation results shows that our scheme can predict the performance by up to 92% accuracy. In the full paper, I will explain the integrated database, various machine learning algorithms used for the prediction, analysis results on applications in Korea supercomputer system and Berkeley Lab, and the evaluation results.
Hi, my name is Xu Wang, the PhD candidate of Texas Tech University, and today I'd like to give a short teaser presentation on our HPDC paper, the PAC, the Page Adaptive Coalescer for 3D Stacked Memory. In this work, we introduced the PAC for the 3D stacked memory such as the HMC or HBM that has been designed for the bandwidth or the data-driven applications, also known as the data-intensive applications. We use the PAC design to optimize the performance, the power usage, as well as the bandwidth utilization of the 3D stacked memory. And this work focuses on the data-intensive workloads with irregular memory access patterns, and PAC enhances the performance by eliminating the redundant memory footprints to the 3D stacked memory. And the PAC design is adaptive to distinct 3D stacked memory devices, as well as their corresponding requested granularities. And if you're interested, please check the details of our final presentation. Thank you.
Good morning. My name is Abel Souza. I'm a doctoral researcher at UME University. On Thursday, I invite you to attend a presentation about ASA, the Adaptive Scheduling Architecture. In HPC, resources are controlled by batch systems and may not be quickly available for use because of long queue waiting times. On the one hand, big allocations guarantee faster workflow execution at the cost of high resource utilization. On the other hand, dynamic allocations optimize resource utilization, but they increase the workflow make span. To combine these two, we propose ASA, a new scheduling architecture that reduces the perceived waiting times and improves the resource utilization for scientific workflows. ASA uses reinforcement learning to learn queue times, and based on this, it proactively submits resource change requests. Experiments in two HPC centers show that ASA combines the best of the two worlds, with reduced workflow make span and near optimal resource utilization. You are very welcome.
Hello everyone, this is Yue Deji. I'm glad to share our work, Aquila, Adaptive Parallel Computation of Graph Connectivity Queries. Graph is a natural representation for many real-world applications, such as social network, code analysis, map, and internet communication network. There are a group of important graph algorithms, the graph connectivity algorithms. For directed graphs, there are weakly connect component and strongly connect component. For undirected graphs, there are connect component, bi-connect component, escalation point, bridgeless connect component, and a bridge. They are widely used in many real applications, such as graph analytics, pattern recognition, and cybersecurity. So in this work, we designed Aquila, a new framework specialized for graph connectivity queries. We designed new computation strategies towards partial computation queries. We leverage adaptive parallel computation strategies with new techniques, and our framework underperforms previous works.
Hello everyone, my name is Shubhendu Behra. Welcome to HPDC 2020. I'm excited to present our paper titled Orchestrating Fault Prediction with Live Migration and Checkpointing. During the full presentation, we will discuss how our multi-level checkpoint restart model, with its ability to predict failures with lead times and fault location, chooses proactive action to minimize the application overhead while effectively utilizing the modern storage hierarchy with burst buffers. Our evaluation of the proposed model is novel in that we utilize the failure prediction outcomes such as fault location and the available lead time instead of relying on statistical models. Our study suggests that both burst buffers and live migration are synergetic in improving the efficiency of checkpoint restart solutions. Please attend the talk for more details. Thank you.
Hi, my name is Garrigan Gregorian, and I am a PhD candidate at Rochester Institute of Technology. I'm glad to present my paper that I wrote together with Professor Yaoqing Liu and my advisor, Professor Minseok Kwon. Distributed computing is highly dependent on fast and efficient packet forwarding between ISPs. The problem we're considering in this paper, BGP route lookup, is the main contributor to packet forwarding delays. Because ISP forwarding tables are large and growing, the route lookup becomes more and more expensive and energy hungry. In this work, we combine two approaches, prefix aggregation and caching, in order to reduce the size of forwarding tables. We built our solution on top of the concept of programmable switches. Our results show an extremely high cache hit ratio and low churn when updating the forwarding tables. I invite you to watch the full presentation to see how we designed our solution. Thank you.
cloud providers sell a variety of lower-priced transient VMs, like AWS Spot, Azure Batch, and Google Preemptible offerings. The downside of these cheaper VMs is the preemption of the VM and its resources at the provider's discretion. Preemptions lead to application failure and downtime, making transient VMs not viable for many, requiring complex handling and being poorly suited for interactive applications and long-running services. We have an answer to this conundrum. By using low-priority transient resources and VM deflation techniques, we allow applications to run at reduced resource allocation. For interactive applications, this means they need not worry about handling preemptions and downtimes. You can find out more in our paper, Cloud Scale VM Deflation for Running Interactive Applications on Transient Servers, where we show real-world feasibility and policies for this technique.
Hello, I'm Ryan Chard from Argonne National Laboratory, and I'm presenting our work on a distributed, federated function-serving platform called FuncX. FuncX lets you turn almost any computing resource into a high-performance function-serving platform. Deploying a FuncX agent on your laptop, supercomputer, or cloud integrates it into our function-serving fabric so you can reliably and securely fire and forget invocations to it. To run a function on a different machine, you simply change the ID of the endpoint that you actually want to use. Our agent works on almost anything, from Raspberry Pis to supercomputers in the cloud. And in my talk, I'll explain how FuncX actually works and show that it can scale to over 100,000 containers on Argonne and NERSC supercomputers, and that it's capable of performing over 1.2 million function invocations per second on a single machine. I also discuss how it's used in multiple science use cases and the lessons that we've learned along the way. Come along if you want to hear more. Otherwise, I'd be happy to answer any questions you have on Slack.
Okay, thank you. Well, I hope you enjoyed this madness session video. It took actually 20 minutes, 22. I would like on behalf of all organizers to thank once more all authors for providing these 1-minute presentations. And now I'm going to switch back to our slideshow. And now I think it's a time to announce the winner of the Best Paper Award. So David, please.
Yes, you can advance slide. Yes, so the Best Paper Award goes to, drum roll.
Yeah, we can not. Okay, I show the next slide.
Yeah, go to the next slide. So it goes to spying on the floating point behavior of existing unmodified scientific applications by Peter Dinda, Alex Bernat, and Connor Hetland from Northwestern University. So I want to say a few things about this paper. I want to congratulate all the Best Paper Award nominees. Like I said earlier, they clearly separated themselves during the review process from the other submitted papers. I also want to say that this Best Paper Award clearly separated itself from the nominees. So it's truly kind of the best of the best. There were many comments on this paper, uniformly positive. I can't actually put all the comments here. So I said some earlier comments. I'll say a couple more comments that the committee had. So the first one, many HPC researchers want to understand the nuances of floating point behavior on production hardware, but are not able to do that because existing solutions follow an intrusive approach. This paper solves that very problem. First-year PhD students should be given this paper as a mandatory reading material on how to communicate science effectively. And another one, the reviewers were impressed by the clarity of the writing and the exposition, as well as the innovativeness of the solution. They also felt that this paper would inspire other papers to follow in its footsteps and that the tool would be useful to other researchers. So I want to congratulate these authors. We will be contacting Peter, Alex, and Connor out of band, get their mailing address, and we'll send you a plaque in the mail. But right now, I just want to say congratulations. I'll give a little actual clap. And with that, Vlad, I will pass it back to you.
Thank you. Thank you, David. Okay, actually we have still one slide to show. I would like to thank sponsors. First of all, it's ACM. So two special interest groups on architecture and HPC, high performance computing, and also Custer Software Research Center from KTH and the University of Arizona. I would like to mention that when preparing the physical conference before it has been canceled to run it physically in March, actually we booked everything. We booked also boat for banquet towards Stockholm archipelago. We booked all lunches and and then we started cancellation process, which was eventually successful to cancel everything. But at the end, I would like, because we are close to the end of the webinar, and because John Weissman, head of steering committee, could not attend it, but just right now, I've got an email forwarded from him. Okay, maybe I should stop sharing this. And so the news is this about HPDC 2021, we asked him. And now he said that the possible location, and as far as I know, Stefano has committed to that, to be in Stockholm again. So it's in about a year from now, in the time close to what we call midsummer. It's June 20th in Stockholm. I will also be happy to be local co-chair once again. And we hope it will happen, and I hope you will be able to travel to our beautiful city and our beautiful country and enjoy Stockholm in June, in summertime. But of course it will be clear whether it will be physical, and I hope it will be physical conference. Okay, we have got some questions in chat, and as I see that people have been able to answer them, our panelists. So now we would like to invite all of you to access the papers and keynote talks in both videos and also review papers, and they're available in several places. First of all, ACM Digital Library. All proceedings are already published. We just got notified about two days ago, so therefore we just put the link recently. You can find the link on the conference website. And furthermore, each and every paper has a video attached to it. So therefore, just be careful, because the page that the digital library shows you, it's a little bit complicated, but eventually I hope you will find out where is the video, and you can download it with Impact 4 and watch it. Furthermore, videos are also available from our program page. Just click on the title of the paper and watch video presentation as well. And furthermore, also you can just go to the HPDC YouTube channel. If you don't have a link, Google for it. You will find eventually where all papers presentations are collected. And also we would like to invite all of you to Q&A and paper discussion on HPDC 2020 Slack workspace. There are channels for each and every paper. You can contact authors and communicate with them live during these sessions and also beyond, because the conference is still running asynchronously. We also would like you to attend, invite you to attend workshops. One of them happens live tomorrow, and another one will have a similar scenario like HPDC 2020. Okay, if any panelists want to say last words, but before passing the microphone, I from my side, and also on behalf of all organizing committee and steering committee and program committee members, I would like to thank, first of all, to all attendees and all paper authors. and those who has attended this webinar, and also to our panelists. But HPDC 2020 symposium, even if it's webinar now, it still continues for 2 more days. So therefore, continues online on Slack, ACM Digital Library, and YouTube channel. And from my side, I would like to wish all of you stay safe, stay well, and goodbye to everyone. So we finish our webinar, if you unmute, we can maybe those two. Unfortunately, I cannot unmute all attendees at once. So therefore, we communicate over Slack now asynchronously. So I push the button and stay safe and stay well to everyone. Goodbye. Goodbye.
Thank you. Bye-bye.
Goodbye. Thank you.